Find an equation of the plane that passes through the point. Hold on here. Equation of plane. So here is the equation: ax minus x naught plus b, and so on, where x naught, y naught, g naught is a point, and we are given that point here: x naught, y naught, g naught. Now if we know a, b, c, which is the normal vector to the plane, then we are done. For that, we know that it's given that the plane is perpendicular to the line of intersection of the planes given by these two equations. So we got two planes. Okay, let's look at here. Okay, just to show you an idea. First plane, let's say second plane, and if they are not parallel, they intersect at some point, and couple of points, infinitely many points, so we get a line. So let's find the equation of this line first. Okay, then our plane is perpendicular to the line, so our plane is just perpendicular to the line, then we'll be done. Okay, so let's find the intersection of these two planes, which is the equation of line. Let's find the equation of the line. Okay, this line, that is the line of intersection of these two planes. For we have x plus y minus g minus 2 equals 0, and 2x minus y plus 3g minus 1 equals 0. And equation of line is, we know that that's x equals x naught plus at in the parametric form, y equals y naught plus bt. Okay, so we can assume a simple point first, x, then we can find y and g. Or let's look at here, we can solve this equation for y, and we can also solve for y. We can solve for x or g, but y, 1, y, 1, y. So let's solve for y and take x equals any value or g equals any value. This implies if we isolate y, we are gonna get, let's move these 3 to the other side, add 2, add g, and subtract x. So this is y equals. Similarly, from the second plane, y equals, so negative, so add y both sides, so y on the other side, so that equals 2x plus 3z minus 1. Okay, now this is y equals, this is also y equals, so we can set them equal. But to make our life easier, to simplify this, we can assume x, just take number t, 1t. Okay, and then set this equal, so we get y equals now 2 plus g minus t equals 2, x is, by the way, t, plus 3g minus 1. Now we can solve this for g. So let's move terms around. Subtract 2, subtract z, add t. Or we want to isolate g, right? So okay, let's do this anyways. So 0 equals 2t, so we have to add t, so 3t, minus z means plus 2z, and minus 2 means minus 3, so we can solve for g. 3t and g move over, so 2z equals negative 3t plus 3, so g equals negative 3t plus 3 over 2, which is same as 3/2 minus 3 over 2t. So that's g equals, so we are like the third part, and first is just x equals t, we just assume this. and which is fine. Okay, and now we need to find y, and for go to here, first equation or second equation, doesn't matter. Then y equals, okay, y equals 2 plus g is here, 3/2 minus 3/2 t minus x, and we assume x to be t. And when we simplify, we get 2 plus 3/2, 7/2, minus 3/2 t minus 1 t, 3/2 minus 1 minus, so negative 5/2 t. So basically we found a set of equations for this line, okay, this is straight line given by the intersection of two planes. Let me write that. Okay, so thus the equations of the line: x equals, we assume t, that is 0 plus 1t, y equals, we found here, and z was found here. Okay, from this set of equations we have the direction vector, right? Because look at this system, ABC is the direction vector. So direction vector, let's say V is just 1, negative 5/2, negative 3/2. So what is this in fact? If we go here, so we just found the equations for this line, and we have the direction vector as well. That means this direction vector we just found gives us the direction of this line. And our plane, okay, our to be determined plane is perpendicular to the line, okay, perpendicular to the lines, and we have direction vector going in this direction, and our plane is perpendicular to this, something like this, I don't know. So this direction vector is in fact normal to the plane, because our plane is perpendicular to the line. That means this direction vector that we just found, this is the normal vector for the plane. Okay, and that was missing when we looked at this formula. We were missing A, B and C, A, B, C. Okay, this is the normal vector, okay, perpendicular to the plane, and we just found direction vector of the line, and this is a normal vector to the plane. Okay, this is a normal vector to the plane. Then we are done. Thus the equation of the plane is A, this is ABC now, A x minus x naught. So let me look at the point, negative 1, 2, 1, negative 1, 2, 1, negative 1, 2, 1. So x minus x naught, x minus negative 1, so x plus 1, plus b is negative 5/2, so this is minus 5/2, y minus y naught, that's 2, plus c is negative 3/2, g minus g naught, that's 1, equals 0. So this is the equation we were looking for, final.